I classify data sufficiency as either or a value question. And in either or, they can be yes, no. For example, they're asking me whether an integer is odd. It's either yes or no. But the point is, for me to be able to answer anything other than echo, it has to be either always yes, always no, always this, always that. If it's a million times yes and one time no, not sufficient. So it has to be conclusive, either always this way or always that way. So that's one type of data sufficiency, either or. The other type is a value question. They're asking me for a value. What is the value of x? And for me to be able to answer anything except for echo, it has to be one and only one value. If it's two values, not sufficient. Now, then I look at the statements. They are evidence that is 100% true. There is no doubt about the truth of the statements. And you can consider the statements to be clues. So they're asking you a question. They're saying, hey, listen, is x a 3-digit integer? And you have to remember not to consider the information in the question as evidence. Okay, they're asking me whether x is a 3-digit integer. I cannot use that as information, as evidence. That is the question itself. And so now they ask me that question, and in this case, it's an either or question. Either yes, either no. I need to conclude either always yes, always no. If a million times yes, one time no, then not sufficient. So they give me these clues, this evidence that is 100% true. Statement number one, evidence that is 100% true. Is this enough on its own to conclusively answer the question, either always yes, always no? And then I consider it alone, okay? Then I consider statement number two alone. Another piece of evidence. They're saying, here's another clue. Here's another characteristic of this integer x. Is that enough to answer the question, either always yes, always no? So I remember to answer the questions first alone. And I'll pay attention, especially when I'm reading the second statement. I don't want to include information provided by statement number one by accident. And remember that the information in the statements will never contradict. So whatever it is that they give you in statement number one, it will not contradict what is given in statement number two. And so I perform that analysis on statements number one and statements number two. So when they give me this information in the statements, and let's say I want to try a number, that number that I try in the statements, it has to satisfy the statement. I have to provide a number that satisfies the criteria provided in the statements. Now here's a nice little shortcut that saves you time. Let's say that you try a number that satisfies the statement. And for the sake of argument, you try a number, and that number, okay, let's say in this case, they're saying x, is it a 3-digit integer? And in statement number one, they tell me x is the square of an integer. And so what I'll do is I'll say, okay, you know what? 9 is the square of an integer. And in that case, the answer to the question is no. Now, what I would do is I could still keep on trying numbers. So I'll say like, okay, 9, then there's 16, okay, then there's 25, and in that case, it's going to be no, no, no. But I want to be a little bit more strategic on questions perhaps that are more challenging, where I say, okay, I have a no, can I find a yes? I purposefully try to flip the answer. So I'll say, I got a no, I want to save myself time. So instead of just trying randomly numbers, let me be a little bit more strategic. Let me try to flip the answer. Can I flip it? And so I say like this, no, can I make it a yes? Let me look for an integer that is the square of an integer that is a 3-digit integer, and then I'll flip it to a yes. So that saves you time. When it's a more complicated question, that decision to proactively seek a flip is very valuable. So I'm trying to disprove. But I'll remember, the statements are always 100% true. Okay, and then I consider the second statement on its own. I try to forget about the first statement. Second statement on its own. And then I try a number. And I'll see, is this restrictive enough to say yes, 100% or no, 100%? No, then I combine the statements. And then when I combine the statements, whatever trials that I'm writing down, they have to satisfy both statements. And then I look at the question. Is it 100% yes or 100% no? Okay? So if they're asking me, is X odd? If it's 100% always no, that is enough, right? If it's 100% always yes, that is enough. But the point is, it's either always this or always that. And if it's a value question, one and only one value. 2 values, not sufficient. So those rules, when you're solving the question, state them to yourself loud in your mind so that you can remember them and so that they're more accessible. It's very similar to verbal. When I'm looking at an argument, okay, I look at an argument and I say, okay, premise, conclusion, and then the question says, what is the assumption? And I tell myself, what is an assumption? It's an unstated premise. This means it's a statement without which the argument would fall apart. It is a must-have. It is a nice-to-have. So I say that in my mind so that I don't forget it. And so it's present, and therefore the analysis when I'm looking at the answer choices is perhaps faster. So again, we recap and we say the rules, relatively speaking, are not many. The quant concepts, they're relatively speaking not many. The verbal ideas, not many, but they have to be extremely accessible. And the way that I can make them accessible is to, as I solve the questions, to repeat them to myself on a regular basis, especially when I answer incorrectly, or when I answer correctly, but I wasn't really sure why the other answer choice was incorrect. And so I say, but why was this wrong? And so I invoke these principles. And I do it on a regular basis. And I do it under time. Because if you know a concept, that is nice, but what matters is that you are able to summon it under time conditions. And that's why solving under time is very, very important. And that's why sometimes when you feel like, hey, but I learned, I know more, why don't I see it as a change in the score? Because it requires a lot of repetition, a lot of drills for those ideas to be accessible unconsciously. That's when you become faster, and that's when you see a change.